Alright, let's try a real life scenario for volumes of a pyramid. Originally, Khafra's pyramid had a height of about 144 meters and a volume of about 2,218,800 cubic meters. Find the side length of the square base. Alright, so there's a lot of information here, and let's unpack it. The first thing that I want to notice here is this is obviously going to be a pyramid, and it has a height of about 144 meters. Okay, so we are working with a pyramid, and the height is 144 meters, and a volume of about 2,218,800 cubic meters. And we know the volume already, which is 2,218,800 meters cubed. And what are we trying to find? We're trying to find the side length of the base. Of base? And what about the side length? We know that it is a square base. Cool things about squares is that all of the side lengths are the same. So let me make that. So what are we looking at? We have a pyramid, and it has to look maybe something like this. Ew, I hate my pyramid. Let me make a better one. Let's see. Square base. Cool. And then it all goes up to the top. Yeah, that's better. And maybe you can draw a better one than me. Okay, so what are we trying to find out? What is the side length of this base? So what is this going to be right here? And since it's a square base, all of these are going to be the same length. We do know that the height up and down is 144 meters. And all of this inside, what can fit inside of it? 2,218,800 meters, cubic meters worth of stuff. All right. What I'm going to do first is I'm going to write out what is the formula of volume. Since that's what we have here, volume equals the base times height divided by 3. Okay, cool. Little bit more about this base. Remember, to find the base, we need to find the side length times the side length. So I'm going to change this actually to reflect that. This base is now going to be, I'm going to switch it to L. And since it's a square and both of the side lengths have to be the same, that's just L times L, which is also the same thing as L squared, okay? So now this is going to be L squared times H divided by 3, okay? We're switching this base now to L squared to reflect what the base is supposed to be, which is length times length. Okay, now let's start substituting all of these values. So we know what the volume is already. 2,218,800 meters cubed is going to equal, we don't know what the length is, that's what we're trying to find. We're trying to find what this variable is. Times H, we do know what the height is. It is times 144. And divide that by 3. So let's just go ahead and use our algebra skills to isolate the variable L here to find out one side length. Cool. So how do we do that? What's the first thing I want to do to start isolating the variable? I see that we have a divide by 3 on both sides. So I'm going to do the inverse of that, which is multiply by 3. These 3's are going to equal 1. So we're left with 3 times 2 million. Oh my gosh, I don't know what this is going to be. What is this? 3 times 2,218,800. We have 6,656,400 equals, wait, 6 million, yep, equals the length squared times 144. All right, what are we gonna do now? I'm going to divide both sides by 144 so we can continue isolating this variable. This on the right side, 144 divided by 144 equals 1. So what are we left with? This length squared is going to equal the 6,656,400 divided by 144, which is going to become, wow, 46,225. And the last step here to isolate the variable L is to square root both sides. So it's going to be square root of 46225. Of course, it's going to be plus or minus 215, but since we're talking about distance, we want to opt for the positive value that's given to us. So the length here is going to equal 215, what unit? Meters. And that's how we can use the volume of a pyramid to find out for a missing side length now, in this case for a base. All right, that's it. Bye.